on IoT hacking in Null Bangalore and OS seasides. His interests lie in IoT and digital forensics and delivered a talk on network forensics in Null. He has also conducted the first CTF for CISCO by contributing challenges on reversing and binary exploitation. He has been a speaker for different universities like SSN Tapar by delivering talks on IoT and application security. So I invite you, sir, to deliver this section. Thank you. Thank you very much.
Okay.
Bhavik, can you check?
Yeah, let me. Can you see my screen?
Yeah.
Okay.
Thank you, Sabu sir. Thank you.
Yeah. Okay. Thanks a lot, Sabu sir, for introducing me and giving this opportunity to present here with different accounts, and it would be a great experience and hopefully for them too. So good morning, everyone. As we all know that we are here for day 2 to understand about network forensics. What do we mean by forensics, and how do we go with a particular investigation process? So this is what we are going to cover in this 2-hour session today. So before that, I would like to introduce myself. My name is Bhavik Shah. I have overall 11 years of experience in security domain. I'm currently working in Cisco Security Tech. I have a CCI to my name, CCI Security to my name. And last but not the least, I am a cybersecurity enthusiast and a keen problem solver. So before I landed into the cybersecurity world, even I was someone who wanted to learn more, wanted to know more about what we mean by cybersecurity, because it's just a buzzword, but it's so much vast, and each day you keep on learning, and each day you feel that you need to it's something that you need to learn more, and also you need to challenge yourself. So that's why I always try to challenge myself. And as Sabu sir mentioned that this year I just took this challenge to conduct the first Cisco CTF in Cisco, along with 6 of other colleagues of mine. So we were a team of 7, which we brought CTF of Jeopardy style, and which had challenges in different domains, and it was liked by everyone. And so it's something just motivates you to always keep on learning and give back to the community. So that's where I'm here to share my knowledge about what I feel about forensics, and how what are the different challenges involved, and how do we go about it. So this is the agenda for today. Um, we start with why do we need forensics, then what do we mean by forensics, then what are the different stages involved in a forensic investigation process, and last but not the least, the most exciting part, a live demo and also a hands-on exercise. Now, before we start, there's a question for everyone. So you can unmute yourself and you can answer, or you can, put in the chat window. So why do you think that performing a forensic investigation might be important? So I would just give a minute for anyone who would like to answer. So I would just repeat the question. So as you can see in the screen also, that why do you imagine or why do you think performing forensic investigation might be important?
To collect evidence um, of something that's happened.
That's good, Jobin. So yes, to collect the evidence of something which has happened. That's good. I mean, yeah, that is one of the primary reason we would do it. Anyone else?
Good morning. Because attacks are always known to the users, so it will be unknown. So we need a investigation, continuous investigation or forensic investigation on the system, so we can prevent our system from the unknown malwares or attacks which are happening day by day. It is increasing every day.
Yeah, absolutely. That's a good point, right? So we always the trigger of forensic investigation or any kind of investigation starts with anything of abnormality we feel is happening in the system, because we know that how would a normal system behave, and if some abnormality happens, that's when we understand that okay, something malicious has happened, something which was not supposed to happen has happened, as a result of which we start performing an investigation to understand why it happened, how it happened. For example, during this COVID times, we understand the kind of investigation which is happening in medical world. Like, they always do the contact tracing. They try to understand that from where the first symptom of the virus happened. So, for example, like few months back, our entire building was quarantined because three uh, flats neighboring to me was a COVID positive patient. So we all had to perform the investigation in the form of giving our samples, serum samples, to understand that if we are also contaminated by the virus or not. So that was a kind of investigation which we see in medical world. But yes, the same kind of investigation also happens in the cybersecurity world or any vertical we can think of. So that's where the investigation becomes very important. Now, this is how we look at an incident response timeline, right? So, for example, like a few weeks back, actually, this happened to one of my friend, where he got a message from where he got a message on his mobile phone stating that this is the link where if you click, you get a cashback of 1,000 rupees, and there was a UPI link. So I am sure that most of us use the digital UPI payment option nowadays, even more during this COVID times. So he was using his Google Pay UPI gateway. So he got a link that click on this Google UPI gateway and you would get a cashback of 1,000 rupees. So my friend thought that okay, there might be some offer, or someone is so kind that today he is giving him 1,000 rupees. So he just goes ahead and clicks on that link. Now, it asks for his UPI ID, 4-digit UPI ID. So without thinking much, he gives his UPI ID, and to his surprise, rather than getting 1,000 rupees, 5,000 rupees gets debited from his account. And I mean, for that moment, he cannot understand that what happened. So so he just called me and just discuss with me and just ask me that like this happened, so what do you think? So I told him that you have been duped. I mean, so I just asked him that what were the sequence of events you made. So he told that I got a message and I clicked on this link. So that's where I told him that, did you verify the authenticity of that message? And so he said that, that is something which I did not pay attention to. So that is when, that is what we call the event which occurs. So in this case, the event was in the form of the money which got debited from his account. And then the way he detects the event is he gets a message from his bank that 5,000 rupees debited from his account. So that is where he detects that, okay, something malicious or something abnormal has happened. Now, the next thing which he does is he reports the incident to his bank. Now, so this first three stages we call as the dwell time. So this is a dwell time where an incident has happened, you analyze that something has gone fishy, and at the same time you also report the incident. So once the incident is reported to the bank or the specific branch where his account was, or the bank where his account belongs to, the first thing the bank would try to do is limit the damage. They would make sure that further amount is not debited from his account. So what they do is they block his account temporarily. And once the account is being blocked, then basically the bank representative understands the sequence of events which happened, which resulted in those 5,000 rupees getting debited. So that's where we call the remediation time, where the first ask is to limit the scope of the damage if it's possible. And the second is, how do you make sure that such events doesn't happen in the future? So in this particular case, once a bank representative understood the sequence of events which happened, the only thing they told him was, and we also see nowadays there are many advertisements from government channels or government forums that never share this UPI IDs or personal information to anyone, even if the bank representatives never share it unless and until you are 100% sure. So that's what the bank representative told to my friend, that never click on such on link where you get a message from just unauthenticated source. So always make sure that the first thing when you see the message, irrespective of whether they are asking for your details or not asking for the details, always verify the authenticity of the message from where it is coming. Always verify whether it's the trusted source or untrusted source. And if you have any doubt, always the only simplest thing you can do is just ignore the message. That's what we call the remediation. And where we do the remediation or make sure that such problems doesn't happen in the future actually brings us the term called forensic investigation. So basically, forensic investigation happens at the end of the incident response timeline. So if you read certain articles or articles from different scholars, sometimes they think, or in those articles they interchangeably use incident response timeline and forensic investigation as the same term, but that's not the case. And incident, as you can see here, that incident response timeline basically starts when the event has happened, and your forensic investigation generally happens at the end of the incident response timeline, where you have gathered all the details. Now you are trying to investigate that how it happened and what you can do to prevent it from happening in the future. So as we looked into the incident response timeline, let's understand the semantics of what do we mean by forensics. So as I mentioned, that forensic is a test, or are basically nothing but techniques which can happen in different verticals. As I mentioned that during the COVID days, we saw the kind of investigation which was happening in medical world. The similar kind of investigation can happen in a criminal world, or it can happen in our cybersecurity space. So it's just a technique to determine the source of the crime or to determine how the crime happened. And The forensics basically gets divided into two branches. The first is called digital forensics, which is nothing but the investigation or the recovery of data from any digital medium. So it can be your mobile phones, tablets, or computer, anything where the information is retrieved digitally or the information is stored digitally. And if you recover from those sources, that is nothing but the digital forensics. The other branch is nothing but the network forensics, which is nothing but more of a proactive, where you monitor and analyze the real-time traffic in your enterprise network with the help of different tap points which you would be having to capture those traffic. So generally, as I mentioned, that this would be proactive, more of a real-time. And considering today's session, we would more be focusing on the network forensics. So digital forensics would be something which you can always retrieve the data, always fall back the time, or you can traverse the time and and fetch all the information digitally. But network forensics is more of a proactive. For example, we all have CCTV cameras, right? So I'm sure that where you would be living, there would be CCTV cameras. Now, one of the primary objective of those CCTV cameras is to monitor the real-time data, like who is entering your premises, who is going out, so that tomorrow, if some incident happens, they can always go back to the time for when the incident happened and then understand basically the number of people or who entered the premise, and then they can at least help in investigating that, okay, these are the primary suspects, and because they were someone who entered at that point of time. So that's where network forensics or basically your real-time data helps. Now, as we looked into the incident response timeline, let's understand that what are the different steps involved in a digital forensic investigation. So these are primarily the 5 steps which I would uh, tell that these are important. So it starts with identification, preservation, collection, analysis, and presentation. Now, generally, if you ask someone that which is the first step in a forensic investigation, now maybe 5 out of 10 would say analysis, because you always want to get into the scheme of things. You always want to be the first one to determine that what exactly would have happened. But that's not always the case, because as we saw in the incident response timeline, the analysis comes much later. First, you need to gather all kind of data to understand that something malicious or something wrong has happened. That's why the first 3 stages are equally important as to what we say, the stage of analysis. Yes, analysis is important to understand that what caused the system to go down, but at the same time you also need to have the data to build your evidence or to build your thesis upon that. Okay, this were the sequence of events, this was the data which I collected, and probably this were the reasons why the system went down. So let's understand each stages in more detail. Now, the first stage is identification. Now, what we mean by identification? Now, as I mentioned, that identification is basically all your sources of data, all the custodians of data from where you would be collecting all the information from. Now, it can be information which you would be collecting digitally, or it could be those information which you would like to collect physically. So basically you first identify what are the different data points from where the data can be collected. Now, for example, in an enterprise network, there can be, as I mentioned, tap points, which would collect your real-time traffic, real-time network data in your enterprise network. Or it can be your SIM servers or your syslog servers, where you would be collecting the data from that particular timestamp. So depending on the evidence or depending on the kind of crime which has happened, you would identify the different data source or data custodians from where you need to collect the data. The second is a preservation. Now, once you have captured or once you have collected the information from your data source, from the data custodians, the next step is to preserve the data. Now, as you can see in the image, you have that yellow tags generally in a crime scene, which says that this are the points where the where the crime happened, and they make sure that no one could enter those crime spots so that they cannot tamper with the evidence, because you have um, you have basically identified the different data sources from where you think that the data or you data can be collected, and also at the same time it can help you in determining that how the crime was created. So that's the important step where you tend to preserve the data or preserve the data source from where which can help you in identifying how the crime was carried. So generally in the crime scenes, you would see those yellow tags, and also you would have seen different movies where they have this kind of yellow tags which doesn't allow any untrusted source, to enter that premises. So you basically preserve all the data and document everything, all the information about the evidence and how it was acquired. So basically you can see the different tags or different bags where you have a tag of evidence, because they were the kind of evidence which was collected from the crime scene. The third is a collection. Now, this basically, once you have all the data at your disposal, basically what you do is you would store it somewhere. Now, the storage can be physical or it can be virtual. Now, the virtual, when I mean, is basically in the form of drives. Now, say for example, you have got a drive where you think that the information might be hidden. So generally, you create copies of those drives. You do not work on the actual data source. You create copies of that data source and try to retrieve the information from that, so that even if you make a blunder in maybe formatting those drive, you always have the backup, or you have the original copy to fall back upon. So generally, whenever you collect the data, you make copies of that and you work on the copies rather than working on the original copies. So that is where what we say the collection stage. Then comes the most exciting part, the analysis. So you have basically collected the information, you have identified the data sources, and now you have also stored the data, and now you need to analyze those data, because you need to understand that how the crime was being created, or basically what were the sequence of events. So this is the most exciting part, and this is where you basically make a name of yourself, where you determine all the sequence of events, and then you say that, hey, I found out the cause of how the crime was being created. And then you basically, after you do the analysis, the last step is nothing but the reporting. Basically you present your findings and in a specific format, and then you present either to your CISO or different executives in your organization, and basically you run them through the timeline of the events of how the different of the different stages of attack which happened and the reason why the system went down. Now, for the session perspective, we would be focusing on the analysis part. So we would be focusing on an incident which happened in an enterprise network, and we have some evidence in the form of, as I mentioned, we would be focusing on network forensics. So we have an evidence in the form of a PCAP file. So we would be focusing on that, and we would be performing different stages of intrusion and different kind of checks, and understand that how the different stages of attack were performed on the enterprise network. So as I mentioned at the start, the exciting part is to actually understand that what exactly happened from the small evidence of data which you have in the form of PCAP. But again, in an enterprise network, it would be much larger than what you see in a small network. Okay, so I have a small quiz, but I would just take a pause here for a minute or two, and would like to have understand, or if anyone has any questions, I would be happy to answer. Okay, so yeah, so I believe everyone would be having your tablets or mobile phone or your system. So just go to this website, menti.com, and you just need to type this code. It's 6814068. Let me start the quiz. Yeah, so this is a code. Just go to menti.com, and this is the code 6814068. Yeah, that's just to make sure that everyone, yeah, I can understand the challenges of having a remote session and also so early in the morning. But yeah, it's generally in the session I tend to have some kind of fun, yes, in the form of quiz, so that you always, sometimes if you feel that um, like my energy is going down, that's the best time. I mean, that's the best way to get it back. So just wait for another minute. I guess we have 37 to 38 participants. So
Bhavik,
yeah,
Vinod here. Can you type the code for menti.com in the chat window?
sure, I will do that. Okay, so we have close to 20. Perfect. Okay, I think we can start. Okay, so the questions would be in the kind of MCQs, and it's a kind of fast finger first. So yeah, the one who gets the maximum answers correct. Yeah, unfortunately, virtually I cannot give you any prize, but if it was physical, at least I could have given some goodies. Okay, so the first question would be coming here. So in which phase of the incident response timeline does forensics come in? So you have 20 seconds, you have 4 options. Is it analysis, report, remediate, or contain? Time's up. Okay. So 11 of them answered analysis and 9 of them remediate. So yes, remediate is correct. So as you remember, I mentioned in the incident response timeline, forensic investigation comes at the end. Basically, when you are trying to remediate, making sure that what can be done so that the event doesn't occur again. And also at the same time, understand that what went wrong in the system to bring it down. Okay, next question is coming. Again, it's faster finger first. Why do we need forensics? So 4 options are identify how the event happened, or prevent event happening in the future, or detect the occurrence of the event, or none of the above. Oh, great. Yeah, so the correct answer is identify how the event happened in the first place. Yes, prevent happening event from in the future. That is also one of the reason we do it, forensics. But the primary, as we heard from the participants, right, that the initial trigger, the reason we do forensics is because there is some kind of abnormality in the system which has happened, or there is some kind of trigger which has happened. Like I mentioned that for my friend, it was some amount which got debited, or it could be tomorrow. Maybe due to COVID, it's in the medical world, someone gets a COVID symptom, or tomorrow, anything, right? In a normal day-to-day life, for example, you are driving and for some reason your car doesn't start that day. So you tend to do a kind of, yes, the investigation would be done by the mechanics, but you always also try to do it yourself, that what did I do with the car? I mean, few days back it was running exactly fine. Was it the weather because of which the car is not running, or the battery died down? So that are the kind of things you ask yourself generally, because how a system is supposed to behave. And if something abnormality happens, that's when you start identifying what exactly could have went wrong. Okay. Yeah. So the last question: which of these are not stages in the forensic investigation process? So is it identification, reporting, analysis, communication, or preservation? So remember, we did the incident response, the forensic investigation process, and there are 5 stages involved in it. Absolutely. So I think most of them got it correct. Yes. So identification, reporting, analysis, preservation are the stages of a forensic investigation, but communication is never the stage. Perfect. So let's see who is the leaderboard. So it seems Rajesh. So yeah, Rajesh is the winner. So a round of applause to you. Yeah, unfortunately, as I mentioned, it was physical. I could have given you a goodie for sure. Okay, so let's get back to okay. So we till now, what did we look into, right? So we looked into the incident response timeline. Then what are the different stages involved in a forensic investigation? Now, as you see in the slide, this is nothing but a cyber kill chain model. Yes, this is taken from Lockheed Martin, but this term kill chain basically comes from a military world. Okay, so this are nothing but the stages of attack which you would perform in order to compromise a system. But at the same time, if you do it reversely, you can also defend your system while it is being attacked. So let's understand what are the different stages in a kill chain model. So the first stage is nothing but the reconnaissance. So reconnaissance is basically understanding how your system is behaving. For example, when the smartphones came, like few years back, like maybe 10 years back, we all we were never used to it. So when I say never used to it, in the form of the different applications which you can download from the Google App Store. So you always try to understand that how the system is working, from where do you download the applications and other stuff. But from an attacker standpoint, you would always try to do a reconnaissance, which can be an active reconnaissance in the form of Nmap, or it can be a passive reconnaissance. So active reconnaissance would be in the form of Nmap, where you try to do an Nmap request to the end system and wait for the response. Now, depending on the response, you understand. So generally, Nmap basically scans all the open ports for your system. Now, so for example, say there is a server in your enterprise network, and you run an Nmap on that server. It would basically list all the open domains or the open ports on which that particular server can listen to. So from an attacker standpoint, you would always try to understand what are the different vulnerabilities which can be possible in a Windows system. So generally, where basically, for example, you know that a CEO for a particular company, and you basically in the social media, you try to see where he is active. For example, say he is active on Facebook. So you try to see that what are the different posts he is making, maybe daily, weekly, and try to gauge his likings and dislikings. And then from there, you basically try to gather as much information as you could. So that is nothing but a passive reconnaissance. Now, once you have understood that the system which you want to target or the system on which you want to attack, once you understand the nitty gritties of it, you try to start the weaponization stage. Basically, weaponization stage is where you build the exploit. So as I mentioned, that once you know what the system is capable of doing, or what are the characteristics of that system, basically you build a payload in the form of weaponization. Now, say for example, if you know that it's a Windows system, basically you try to identify that what are the different vulnerabilities which can be possible in a Windows system. So you build your payload, and that's where we call the weaponization phase. Now, once you build your weaponization, now you need to deliver to the end system in order to get it infected. Because unless and until the payload which you created doesn't go to the end system, the system is going to work the way it used to work before. So now the third stage comes where you need to deliver the payload. You basically deliver the weapon which would compromise the system and which would help the attacker in fetching the critical information. So generally the delivery would be in the form of email, and the next talk is going to be about email phishing. So that is something where you understand that how do you determine whether an email is authentic or basically it's a phishing email. So email is one of the primary source, but the other can be a web. Now, all we we being technocrats, we always look for free things or free software, right? So we always go for links where the free software is available. Now, generally, when you click on that link, there are 10 different hyperlinks which get opened, or there are 10 different applications which would get installed on your system. Basically, it just asks for your permission, or sometimes it doesn't ask for your permission, it just runs at the backend. So that is another kind of payload delivery which can happen. And the third, now rarely used, would be in the form of USB. The USB is mostly can be or the USB mostly would be beneficial in the medical equipments, because today most of the medical equipments are IoT connected. So they have a USB port, and if someone enters your health, if someone enters a hospital and tries to connect the malicious USB in the system, the entire system goes corrupted. So generally, mostly we see that usage in the health environments. So once you have delivered your payload, and once it gets installed on the end system, basically your exploitation stage starts, where you have made sure the payload which you created was delivered successfully to the system, and once it got installed, the system is now compromised. So that is what we call an exploitation phase. And generally the exploitation, the installation goes hand in hand, where once the payload which you have created, which is malicious, once it's installed on the end system, basically it opens a backdoor channel to the attacker machine, and whatever critical information he's looking for, or if it is a Windows machine, basically it can execute some kind of PowerShell scripts to fetch some critical data or some credentials file from your critical server in the enterprise network, uh, and basically it would retrieve that information to the back channel, or the back channel which it has opened with the help of the payload. That is where we call the command and control um, stage, where once you have once you have made sure that the system is compromised, you want to extract certain critical information. So basically you execute some commands from your command and control server to the back channel, and then basically you do all the actions on objectives stage. Basically you fetch all the information which you want in the actions on objective stage, where as I mentioned, that say for example you want to retrieve all the files which have the critical password saved in it. So basically you can fetch those information in the actions on objective stage through the command and control server with the help of the uh, channel which you built using the payload which you installed on the end system. So generally these are the 7 stages of attack, but at the same time you can always defend your system from the attack which is happening. For example, in an enterprise network, we have this intrusion prevention system, or which has different signatures built for different applications. Now, say for example, generally your intrusion prevention system would be installed at the edge of your enterprise network, where your traffic is supposed to enter in your network. Now, once the weaponization, for example, let's assume that a weaponization phase has been started, it is trying to send the payload through an email. So your intrusion prevention system basically would detect the signatures which is there within the payload, and once it triggers an alert that this looks to be malicious, it would basically block that particular communication from entering your critical servers, so that your network is defended. So at that particular stage, the attacker is basically at the weaponization phase, but in a negative state, where he was not able to go inside the system because of the intrusion prevention devices, which basically detected those signatures and alerted the network admin, but also at the same time made sure that your system is not compromised. Okay, so it's been too much of talk. So let's dive into the most exciting part. It's a live demo and a hands-on exercise. So what's the time? It's 10 o'clock. Shall we take a break of 5 to 10 minutes and then we start, uh, or we continue? Let me know.
So can I ask a question?
Yeah, go ahead. Yeah.
So what is the signature basically?
Yeah, so signatures are basically, so each application, right? Now let's assume that an FTP. So signatures are basically you define the pattern, the way the application is supposed to behave. Now in FTP, there is an active FTP and passive FTP. There are 2 different modes of FTP. So forget about the modes, but I would just give you an analogy. Okay. So as active FTP and passive FTP, the only difference is basically in active FTP, the client decides what are the ports on which the server is supposed to listen. And in a passive FTP, the server tells that this is a port on which you have to communicate to me so that you can retrieve any data which you want. Now, in an FTP, so it basically works on a TCP protocol, TCP, which is a connection-oriented protocol. So once that TCP connection is being established, now let's assume that it's a passive FTP. So what would be the sequence of events? The server sends a passv command stating that I am running in passive mode, and also at the same time gives the IP address and the port on which the client has to connect to. And the second stage, the next stage would be the client connects on that IP and the port to get whatever data he wants. So this is nothing but a pattern. Now you build your signatures on the basis of this pattern. So what would be what you look in that pattern is if it is a passive FTP, you should look for passive command. So basically in the signature, you would write that I should get a regex of say passv. Apart, if it is not passv, then the signature, then it means it's not an FTP application. So the first condition for your signature would be if it is a passive FTP, you should get a passv command. The second condition would be you should get an IP address of the server and also port on which you are supposed to listen to. So what you do is basically on your regex, for the second condition, you would build a regex which should match an IP address, which can be any 0 to 9 digits. And also at the same time, it should have a port number, which would be from 0 to 65535 range. Now, if you get any value which is not matching this, it means it doesn't hit your signature. It means it's not an FTP protocol, it's some other application. So that's how you build your signatures. Does that answer your question?
Yeah, I understood. That means we are setting the rules if it is a passive or active. According to the passive, these are the IP address and ports for the particular application. It has to be set. If it is not there, then it is somewhat malicious. So on that basis, we are saying it as a signature. Am I understand this right or wrong?
Yeah, exactly. So if you look at, right, so 10 years back, everything, whatever security systems or whatever firewalls we had, it was all till layer 4. Now, what I mean by layer 4 is it was just IP address and the port number. But since now the security threats are evolving with new applications which are coming, you cannot just protect your system with just a layer 4 rule. So what you do is basically you create your layer 7 rules where you create those application because you do not know that tomorrow the traffic is supposed to come on FTP port 21. So for FTP the port is 21. Now tomorrow it is possible that on port 21 there could be some other kind of traffic which might be coming. For example, there might be an HTTP traffic or there might be some kind of UDP traffic which would be coming. So if your rule says that if it is port 21, just allow the traffic, assuming that, so what are you assuming is that I'm going to receive FTP traffic only on port 21 and no other application traffic is going to come on port 21. That's not the case. Now today, what I can do is if I am an attacker, what I can do is I can just send a malicious code in a port on port 21. Now, since your system allows port 21 traffic, that malicious code just enters your system and enterprise crosses your enterprise network, enters your enterprise network, and then compromises your system. So that's why you build now signatures where you create small modules of different regex patterns, and if everything matches that, then only the traffic is allowed. I just gave an example of FTP, but you can take, for example, HTTP. And now, what are the sequence of steps for HTTP? And now, if it is a client, you would always see a GET request if the client wants to get something from the server. Or if the client wants to send something to the server, you would see a POST request. But apart from the GET or POST, you won't see anything at the start of an HTTP communication. Now, if you don't see either a GET or a POST, but you see a port 80, which is a standard HTTP port, you'd still classify this as a non-HTTP traffic. Why? Because the port was matching, but the signature or the pattern on which you determine whether there's an HTTP or not HTTP, that is not matching. As I mentioned that for HTTP, you would either see a get or post request at the start of HTTP communication. But let's assume you see a traffic which is on port 80, but you're not seeing any get or post request, which means it's not HTTP traffic. So if your rule, which says that if it had a rule, which is a layer 7 rule on the basis of the signature which you created, which says that for HTTP, I should have get and post, then it is allowed. But if it is not get and post, do not allow. So if that is the case, it means if I am an attacker and I'm creating a HTTP payload on port 80, but without get and post request, I would never make through your system because the application signature doesn't match. And then you have an action on that, that if it doesn't match what you want to do, you want to block it, then that particular payload never enters your system. So that's how you build. That's what you mean by signatures, and that's how you create your rules in today's world. I hope that answers. Yep.
Yeah, thank you.
And I was a senior, I used to mention.
Sorry.
Thank you.
Okay. Okay. Sir, shall we take a 5 minutes break? I think it's 10:10, and then we start with live demo. Or if everyone is okay without a break, we can start.
Sir, I have a doubt on the installation. Hello?
Yeah.
Can you hear me? Yeah. I have a Workshop of 3.2 version. So 3.4 is when I trying to update, it is not getting updated. There is a TCP dump file is running behind, running. It is not closing. Because of that, I can't update the software.
Okay. I mean, you already had one version of Wireshark running.
Yes. 3.2 is there, and I'm trying to update 3.4. You send a 3.4 version. While doing that, I'm facing the problem of TCP dump is already running. I went to I opened the taskbar. I'm trying to end the task, but it's not ending up. So I don't know why.
So, I mean, I just shared the link from where you can install the Wireshark. But if you have already a 3.2 version, that should be fine. So, if you're, I'm not sure why your system is not allowing. Generally, if TCP dump is not running, it should allow.
Yeah, I already did, but I don't know why. But in a taskbar, there is a task manager. There is a TCP dump file is running. I'm trying to end up the task, but it is not ending up. Is there any reason for that?
I mean, so tell me one thing. So the current Wireshark image which you have, can you load the PCAPs which I've shared? Yeah, just try that. If that works, all good. You don't need to update to 3.4. I mean, that should be. I just gave the link because the link would always give you the most recent version to download. But if you also have a version which is lower than that, it should work.
Okay, thank you.
Okay, so I think everyone is not interested to have a break, which is good. Okay, Murli is saying yes. Okay. Okay then. So let's break for maybe it's 10:10, right? Let's take a 10 minutes break or maybe a 5 minutes break. Let's meet in 10:15.
Okay, sir.
Okay, perfect. So yeah, in the meantime, if anyone has any questions, yeah, I'm happy to answer. So let's meet in next 5 minutes. We are going to start the live demo. So once you're back, just maybe in the chat window, just put a hand raise or so that we just come to know how many of them up. If you don't want to ask during the session, maybe you want to type there. That's a reason that I just put that talk. Yeah, otherwise it's more of a fun to have an interaction rather than, you know, something asking the question in a silo. So okay, so let's wait for another minute and then we start. I hope everyone is back. So anyone having any issues in accessing the drive link, downloading those captures? I believe no one should be having an issue. Okay, perfect. Okay, so I think let's start. I think here.
Actually, the download zip file is not downloading. It is taking time. Individually, we are downloaded it, and the one file is empty. That question file is.
Yeah, that's empty. As I mentioned, that was if you wanted to just post your questions there, that's why. Otherwise, yeah, it's empty. Okay, so let's start. So yeah, I hope everyone has joined, and let's start the most exciting part. We had basically understanding of how the forensic investigation process, and you know, we also had a quiz too, and most of them did excellent, where I believe you understood the different forensic investigation process, and also the incident response timeline. Now, as I mentioned at the start, that with time constraint, we would be focusing on the network forensics part. So let's understand. So in this particular case, we have got an incident that a security breach has been reported in a financial organization called Dummy, and some confidential files were being leaked online. And it is suspected that the laptop or the system of the CEO, John Doe, was compromised. Now, basically, the CISO contacts us to identify the source of the breach and, most importantly, how the breach happened. So, as I mentioned in the incident report timeline, an event has occurred. So, some confidential files are being leaked from this financial organization, and the CISO has basically contacted us and mentioned that, you know, the CFO was being compromised. Now, these are the data which is available, approximate timestamp of the issue, the IP address of John Doe, which is 192.168.10.10. And as I mentioned, being a large enterprise network, there were network tabs or network collectors in place, which was collecting all the proactive data. I mean, which were collecting the data proactively, and they basically provided us the capture in the network, which was running. And basically the email of the CFO they have provided, which is jdo@dummy.com. So basically, this is the data which is available to us. Basically, they gave a network capture and also the IP address and the email ID. So once this incident comes to us, these are the questions which basically you would ask, that where the user contacted the malware from, what was a malware file, what kind of the calls does it make, or does a malware make to the internet, does it try to propagate internally through some script, or how does it fetch the information through different networks or different servers within the network, and what are the possible network traffic signatures which from where you can determine that, you know, what was the cause of the system getting compromised. So let's start. Let's take a pause here and let me open the capture. So yeah, this is that forensic final 2 PCAP. This is a PCAP which I shared in the drive link. So basically, this is the capture which the company provided to us for us to investigate. Now, And basically this is the only source of information they have, the network PCAP, to understand that how did the system got compromised. Now, if you see, this is how a PCAP, so this is the Wireshark utility where you open the PCAP, and this is how it looks. So as you see that this, the first thing, the first column is the timestamp where that particular packet was recorded, the source IP, destination IP, which particular protocol, then what is the length of that packet, what is the IP ID, and the different information. So this is the information, whether it's a SYN packet, whether it's a data packet, all those information basically is given by the Wireshark itself. Now, generally, the Wireshark basically gives you all the information related to your OSI layer stack. So I believe that everyone would be aware of the OSI layer stack, which starts from physical layer to the application layer. So all those layer 7 information from layer 1 to layer 7 information is recorded and being displayed in this PCAP. Now, generally in an enterprise network, so if you see, right, in an enterprise network, the PCAP would be very large. So you need to have certain filters in place, or basically you need to gauge this data. Basically, you need to understand this large data and break into pieces, and then understand that, from what I can derive from this particular source of information. Now, I'll just take you through the different options which are available in Wireshark. So if you see here, you have a statistics where it tells you under statistics there is a protocol hierarchy. So if you click on that, yeah. So if you see here, it's loading. It's a large PCAP, so it just takes some time to load. But generally, you would also have gigs of Wireshark captures. So yeah, you need to be patient and running all these filters. So yeah. So if you see, this is a protocol hierarchy. And as you can see that all the packets are IPv4. 30% of the packets are UDP. 68% of the packets are TCP. And maybe small percentage of that TCP packets are HTTP, and the rest is normal RPC calls. So the first step which you do is understand that what are the different protocols at which the communication is happening. Now, once you understand this data, basically, you come to know that, okay, UDP is the maximum, TCP is the maximum traffic percentage which is there, like close to 70%, and the rest of that is UDP. And most of the frames, IP frames, are IPv4. Okay, so this is a first kind of data or first kind of analysis which you do. Again, we are nowhere close to how did the event happen, but we are just doing the initial scan to understand that, okay, which are the different protocols or which are the different IPs which it is communicating. Now, the other thing is conversations. This would give you one step more information than the protocol hierarchy. So it's still loading, but still, as you could see here, once you go under IPv4, you would see again the source, the IP address. This is a source IP, destination IP, and basically the number of conversations. So the number of packets which were transferred. So from this, what you get two information. One is the IP address, and the second most important information is you come to know that which are the top talkers. Now, when I say top talkers, is the way you determine top talkers is the amount of data which is being transferred between the two endpoints. So if the amount of data which is transferred between the 2 points is more, then you do not mark them as malicious straight away. You just tell to yourself that, okay, from the entire conversations, maybe this maybe from a list of 1,000 conversations. These are the 10 list IP address where the data which was transferred was maybe more than 100 MB. And as a network admin, you know that what is a maximum data size, or what is a maximum data which can be transferred at a given amount of time, or maybe at any amount of time, right? Because you know that what are your critical servers, what is the size of your critical data, and on an average, what would be the amount of data which would be transferred from that server to different endpoints. So basically, those calculation you do it by looking at the packets which are transferred or the bytes which are transferred. They are one and the same thing. And similarly, you can look for the TCP communication. And similarly, you could look for UDP communication. So the first thing which we did was we did the protocol hierarchy. The second was the conversations which he looked into, right? Okay. Now we know that the IP address of JDO was 192.168.10.10. Now let's understand. So we were being told that we have been given the IP address and also the email of the CISO. So let's try to see that if there was any email which came. So we just go to, so there is an option of a find packet in Wireshark where you mention, so these are the different options. So in this case, I've selected string and I've just mentioned packet details. And I've just given, I know the email ID is JDO. So I've just given JDO and I'm trying to find it. So as you could see, it's finding it. So what we are trying to understand is, if you remember in the cyber kill chain model, before the system gets compromised, the first stage is reconnaissance and the next stage is weaponization, where you build the payload and also deliver it to the end system. And as we saw in delivery, the different ways would be either it would be an email, or it would be through a web, or it would be through USB. So the reason I'm doing this investigation is I want to see that if there was some email which was being received by JDO. Now, as you see here, I have searched for this string, and let's see that if I see anything in JDO. Okay. So as you can see that this is the email ID, right? jdo@dummy.com. And if you see in the PPT, this was the email which was being given to us. Dummy is the organization. So again, this captures, I have just modified it. So just from a session perspective, but yeah, when you take an actual PCAP, you would see a valid organization name here. Now, so from this, I can at least tell one thing for sure, that there was some kind of email which was received by JDO. So in order to understand that what was being sent in that email, now you cannot go back to the CISO and say that give me your entire history of emails which you received. That is kind of privacy. Why would someone give the emails which he received for that particular timestamp? He says that this is the data source which you have. Try to investigate what you can do from this data source. You cannot just ask for another data source. Yes, as a forensic expert, you can ask for more data, but it is at the user's disposal whether they want to give or whether they don't want to give. So what I do here is, there is an option in Wireshark which is follow TCP stream. Now, what do you mean by follow TCP stream? For example, let me give you an analogy. Like we do UPI transactions, right? I believe most of us would be doing it. Now, say for example, I want to see a transaction which happened 5 days back. I cannot recollect what transactions I did, 5 days back. And so if someone asked me that, can you check that at this particular timestamp, did you make this transaction? So what I would do, I would just go to my UPI app and just do the transaction history and just check for that timestamp, whether, what amount I got, what amount I transferred. Similarly, follow TCP stream is basically gives you all the data which was transferred for that particular source and destination port between those source and destination IP address. So in this particular case, the IP address which we are involved is 72, 73, 73, 22 and 10, 10, 0, 20. So I just do a follow TCP stream. So yeah, so as you can see, it's just loading here. Let's wait for a minute. So it would basically just give you what I mentioned, the transaction history. It would just give you a history of all the transactions which happened for that particular source and destination port between those IPs. Okay. So okay, so I guess you can see my screen, right? Yeah. So as you can see that there was some kind of email which was being received. Now, who was the sender? The sender was any@mailbot.com. And who was a recipient? It was Jado, the CISO. Now, as you scroll down, so what was the email content he got? Hello, Mr. John, please find your travel itinerary. In case of discrepancy, please reach out to us. So this was the email which he received. And also there's some kind of attachment. As you can see, it's a travel itinerary.docs. And there is some content which looks to be this, right? So let me scroll down. Yeah, and this is where the email ends, right? So let's copy this data. So we know that there was a mail received by Jado asking for some, telling him that this is your travel itinerary and this is the file which was being shared. So let's try to copy this. So let me put it in a tool. Yeah, so this is nothing but just a tool which converts. So from this, right, why I went to that tool. So always remember, there are different data encoding formats in which the data which would be sent. Now, in a cybersecurity space, you would always see the data not being transferred in normal language, which we understand, right? Normal ASCII characters would never be there, because if that's the case, then anyone can detect it. So in this particular case, the data encoding format is base64. Why it is base64? Always remember that if there is this equals at the end, it means it's a base64 encoding format. That's why I just open this converter, which is it's an online utility which converts a base64 to a file, because we know that there was some file which was being transferred in the form of an attachment, right? So let's copy what let's paste what I have copied from there and let me decode. Okay, so I see this application.docs. Okay, so remember, when you're doing a forensic investigation, as I mentioned, always make sure that the investigation which you're doing is on an isolated VM. It's not on your laptop. Yes, for the session perspective, whatever content I have prepared or whatever content you're seeing here, it's not malicious. But from an investigation perspective, that's what we say in a cybersecurity world, right? Never trust anyone. So never trust your friend also. If he is asking you to open any document, make sure you're doing in an isolated network, not in your office laptop or in your university laptop. And when I say an isolated laptop is basically, or an isolated network is basically, it doesn't have any internet connectivity. Why? You have to make sure it doesn't have any internet connectivity, because the moment you download the file, as I mentioned, that the weaponization phase would kick in. It could be possible that there might be some scripts which would be running in that document, which might communicate to your command and control server, which would be sitting on the internet, and then the back channel would be opened, and they might steal any data from your system. So always make sure that the investigation which you're doing has to be on a VM, and that too on an isolated VM, which doesn't have any internet connectivity. So I download this file. Okay, now let me open it. Okay, so if you see here, right, again, this is from a session perspective, it just has this content. But in if you have received a phishing email, you would have more content than this, but you would always have a link to click upon. Now, if you see here, if I hover on this link, right, it basically it's some malicious URL. So if you see here, it's like C165 some domain, and then there is some image file which is getting downloaded, right? C165, and then there is an image name u6wv.png. Now, as a normal user, I won't just actually verify the domain to which it is taking me through. So this might be some malicious, command and control server from where it would try to install or maybe install this particular image on the end system. So in this particular case, Jado received this email. He clicked this link, and basically what happened was this image got downloaded. This name, I believe everyone can see. I've just put the cursor there. So this was the image name, u6wv.png. Okay, so let's get back to the PCAP. So what we saw till now, that there was an email which was received by Jado, and the email had a travel itinerary in the email body, and there was an attachment which took us to a link and then install that image file. So basically, in the cyber kill chain model, so what we have done till now, if you see here, basically we did the reconnaissance. The payload or the malicious file has been delivered through the email, and it has also been installed successfully because the user just clicked on the link and it just clicked on that link, and the image file was being downloaded. Okay, now let's see that what is there in that image file and how it got downloaded. Now we know that the IP address of the system, the compromised system, JDOS, is 10.10. So the way you filter here is IP.addr is the filter, and then equals is basically if it matches this IP address, give me all the results. So I just click on that arrow and it is scanning. Okay, so if you see here, this is the IP address on which it is trying to communicate with different IPs, right? There are some public IPs, 3030, and there are some private IPs within the network. 10.197, which would be a different network, but still, it's a private IP. So this is the entire communication which is happening on that IP, 10.10.10, which is our compromised machine. Now we know that there was a PNG file which was being downloaded, right? Now, as I mentioned, that you cannot go back to the CISO and say that, give me the system where that particular image file was being downloaded. If he's courteous enough, he would share the image file. Otherwise, he would have deleted it. But the question is, can I retrieve that file? Can I analyze that image file which was being downloaded because of which the system got compromised? The answer is yes. Now, in the Wireshark, there's an option of exporting objects for different protocols. So as you can see, HTTP, TFTP, SMB. So we have different protocols on which you can export the objects. So let me click on HTTP because I know that it was a link from where it took me to HTTP link on where the image file was being downloaded. And we know the image file, it was starting from UV and it was a PNG file. So let it get finished in scanning. Okay. So if you see here, these are all the HTTP objects which were transferred on HTTP protocol. So the file name used to start from okay, let me do this. Scanning. Okay. So if you see here, this was the image name, if you remember, right? This was the PNG file, which it basically clicked on that link and it was being installed. So if I go to export objects, HTTP. So basically you can see there are some text files, there are some HTML files, which generally would have some metadata, but it won't have any data which would be of interest to us. So let's try to find that file. Okay. So if you see here, this is a PNG file which was being downloaded. So you can always download this, save it. So I am saving it to my end system. Again, just a word of caution, always do it in your VM. So this was an image file which was being downloaded on the JDOS machine, right? Now, I hope the image is visible. Yeah, it's a good, it's a red image, red background image. Now, with naked eye, you would see that, all looks good. I mean, can anyone point out that is there any suspicious in this image file? I mean, with naked eye. So do you see anything which is suspicious? I mean, if I look at the first time, I would say that it's just a red image. I mean, nothing looks suspicious. Anyone? I think we got a chat. Okay, no. Okay. Okay. So yeah, generally, that's how the forensic investigation, fun starts. So yeah, this is an image file which we built, right? Which we just try to modify something, which I would now reveal those secrets. But if you look with naked eye, right, on the left side, this part, something looks fishy, something looks broken. If you see more carefully, I think, if you have the Wireshark you can always download that image. But if you see, this is the part where, it's something is broken, because if I do here, nothing looks broken. Everything is like synchronous. So with naked eye, at least I can say that, okay, some changes has been done in this image file. Now let's try to understand that. Yeah, with naked eye, I cannot convince myself what exactly has been changed. So let's try to investigate further that what exactly got changed. So what I do is basically I open my VM, and I hope you can see my screen. Is basically I use a Python utility to understand that what basically parameters got changed in that image file, right? Because with naked eye, we can see that, okay, there's some distortion in the image, but let's understand that what got changed. So there's a utility called this PIL, right, in the Python, which you can use other utilities, but I think this is the most frequently used, where basically it gives you the RGB characteristics of, and also the pixel value of your image. So what I do here is I run a small script to view all the RGB parameters in that image. So if you see here, I'm just opening that image. This is the image name. For each height and width, I'm just want to get all the pixel values in that particular image. So if you see here, 255 means R. So the first is red, second is green, the third is blue, and the fourth column is nothing but the opacity, to determine how transparent the image is, how far you can see inside the image. So all this looks good, because generally the values you would have 255 generally. But let's see from the start, right? So this is a start where my, since it was a red image, that's why you see all 255, right? The first column being 255. And since there was no traces of green and blue, it is all 0. But if you see the last column, the opacity, apart from 255, I mean, starting from this value, right? Yeah. Starting from this value, all is 255. But before this, I do see some random values, where sometimes it's 130, some random decimal values, which is not 255. So this looks something suspicious. Maybe this is the reason why that image is being seen as distorted. So let's try to investigate further. Let's try to print all the opacity values in the fourth column. So I run the script again. So if you see here again, what I'm doing is the height and width of the image. What I'm doing is basically get all the opacity values of the fourth column, all the pixel values, and I'm just converting that to bytes. And if you see here, these are all the byte values for all the opacity values, right? The last column, which you are seeing here. So basically, I printed all the values which are there. Basically, I converted that to bytes, and this is the output which you see. So these are all the byte values. Yeah, so you have some printable values, printable characters, and some non-printable characters, right? Like this one. But so it just ends like this. It just gives you some non-printable characters. But if you see here, right, I'm seeing something, some 9-digit value, which says no crawler. Now, what it can be, right? If I ask myself what it can be, because only this 9 digits are, I'm getting some printable characters, the rest are non-printable characters, which means that this might be some kind of encryption key to decrypt the message which I have here. I would repeat, this is some kind of encryption key to decrypt the message which I have here, because this looks to be some non-printable characters, which doesn't make any sense. Which could be, which tells us that there might be a possibility that it could be encrypted, which can only be decrypted with this key. And by doing all the permutations and combinations, you at least came to one conclusion that, okay, this is the key and this is the text with which it needs to be decrypted with. But now which encryption or decryption algorithm is in place, that is something, the another thing which you have to now try to research on, right? That you, first thing, you analyze 50% where you understood that, okay, there is some kind of key which is going to decrypt this encrypted text. Now, what is the encryption algorithm? In this particular case, the encryption algorithm which is being used is RC4. So with RC4 encryption, I can use this key to decrypt the text which I'm getting after post this R, right? So let me collect all this non-printable values in a file, and then I would decrypt that with this particular key and see if we are getting anything. Okay, so let me define first a variable out, and then let me save all. So basically what you see here, basically I'm not taking the key value. Basically after the key, whatever characters are getting printed, I'm saving it a variable out. So basically it just, I saved all the variables in out. Now let me save it to a file. Okay, so I basically saved everything in this particular file, which is pixel. So let me copy this. Okay, so basically what we did till now, basically I parsed the image, got the key, and also got the encrypted text in a file called pixel. Now, as I know that it's a RC4 encryption, so I can go online. You can use any utility to decrypt. So I use this RC4 utility. So I just tell that it's a file. And the key is no crawler. Voila. So I get something, right? So if you see here, there's a build for the session, but on a real scenario, on a real world, maybe you would see a script which is being hidden in the pixels of the image. So in this particular case, we have this. So in this particular case, what the script does is basically defines an array and then converts it to each element, converts it to character, and then prints it. But ideally, in an ideal world, you would have some PowerShell script if it is a Windows environment, or some bash script if it is a Linux environment, which would run at the backend and then fetch all the information which you need, right? So this is how the malicious code or the script was being installed with the help of an email which had an attachment through which the image file was being downloaded and installed on JDOS machine, and then this particular script ran on the end system, so that with the help of this script, basically it builds the backend channel with the command and control server which is sitting on the internet. Now, from a hacker perspective, from an attacker perspective, it basically it ticked two checkboxes, right? It basically made a successful delivery of the payload and also successfully installed it on the end system. Now the last stage remains is command and control executions, or basically what we call is action on objectives, where I want to steal some critical information from the end system. So let's see the capture again, and let's filter with IP 10.10.10. Uh, is my audio not working? Am I audible?
Yes, sir.
Yeah. Oh, okay. Perfect. Thanks. So what we saw till now, that there was an email which was received. Through that email, there was an attachment and an image file was being downloaded. Now, let's see that has the hacker retrieved any data from the end system, right? Now, basically, so you try to look for any communication, any TCP communication, any UDP communication which is happening with this IP address. We know the infected IP is 10.10. With some other IPs, maybe an IP which is on the internet, or maybe some IP which is locally. Generally, the hackers would be sitting on the internet. So the attack might happen from the internet, or it can just compromise another system which is within your network, and then compromise other systems which try to communicate with each other, right? So in this particular case, the initial communication we looked into, and we saw that the image was getting downloaded, right? Now let's see, in this particular case, there's an interesting communication which is happening between 10.10 and 30.30, which looks to be a publicly facing IP address. So again, let me do a follow TCP stream, and it would take some few seconds to scan. Okay, so if you see what is the data which you are seeing here, it says that this is a secret channel. That's it. But it does reveal some, it just gave us some hindsight that, maybe we need to look for another communication where if some more information is revealed or not. Because in this particular case, it just says that this is a secret channel. So let's look for other communications. So again, I filter for 10.10. So you always have to look for more data. So you just have to look for more hints. So in this particular case, it says this is a secret communication channel. So we already know that we already did a follow TCP stream for this port, right? This source and destination port. Let's look for other ports, which maybe starts with this 8000. And now the most interesting part is, now it is coming from the reverse direction, where the server is initiating, or the hacker's IP 3030 is initiating it to the infected IP 10.10.10. So if I do a follow TCP stream, nothing. dot dot dot. So do we conclude ourselves that no data was stealed? Maybe, but let's see if there's something else. So remember one thing, right? Whenever you do a follow TCP stream, there is always a data payload which gets transferred within the TCP header, right? Which you can see from here. And you can always see the hexadecimal value here, which is a dot. So one thing which we are sure is that there's no data which is being exfiltrated using the TCP communication. Is there anything else which we can look for? Something else which is suspicious? Let's look for it. Timestamp looks good. IP address looks good. Protocol, we saw that in TCP there's no data which is being exfiltrated, or there's no data which is being transferred. But let's see here. Now, generally there's identification fields, right? They are part of your IP header protocol. So within along with the IP information and the version, it always has the identification field. Identification field is just a unique number which is assigned to each IP frame, right? So generally, if you look, this values would be in thousands or in 10,000s, not less than that. So generally it would be 10,000, 11,000, or here, if you see, it's 4734, right? But let me look at other values, right? So it is here, it is 40735,103. Okay. So if you see here, it starts, as I mentioned, that generally it starts with 10,000. I mean, generally the value is in 10,000s, but here I see a value which is 103, then a value which is 105, then a value which is 118, which looks suspicious, isn't it? And if you just follow the stream, I mean, if you look for other packets, the pattern remains almost consistent, where I see a normal value, then I see an abnormal value. Again, why it is abnormal? Because generally you won't see an IP ID which is so less, which is a 3-digit value. And the another hint which I get is this is nothing but the ASCII characters, because if you see here 101, let me show you. So 101 is nothing but alphabet value E, right? So which means this is something suspicious. It is trying to basically send some message to the application which is running, or to the script which is running on the end system, that it is trying to communicate secretively, right? And in the form, and that message, it is sending it in the IP ID field and not in the normal data payload. And normally your intrusion prevention systems would generally look for TCP payloads, but it would never look for the IP ID payloads, because generally no one tries to tinker or no one tries to change the IP ID values. But in this case, we do see that there are some abnormal IP ID values. So what do we do? So in this particular case, what I would do is, you always have an option of export export specified packets. So now imagine this is a large PCAP, right? This is like few maybe 200 300 MBs PCAP. But say tomorrow you got a 1 GB PCAP and you have identified the interesting conversation which is happening here. So, and you want just to focus on that conversation. So what you would do is basically you would apply a filter here. Like in this case, I did the IP address and the IP value, because we know 10.10 is the compromised IP address, the system IP address which was compromised. So once the scan is completed, I can always export specified packets and create another PCAP file. I would say that filter, maybe any name that you want to give, right? And I just save it. So that the advantage of this is basically I've reduced my data sample size from 1 GB to few MBs, and then I can parse my analysis on that and then come up with the end conclusion that how was a system compromised. So in this particular case, I've exported that file. Now what I would do is I would run an analysis on that, right? So I use a scapy utility in this, which is again a Python utility, which you would more frequently would be using to analyze large network PCAPs. So in this particular case, let me do that. Okay. So if you see here, what I'm doing is I'm reading. In this VM, I just gave a name as forensics filter.pcap. And what I'm doing is I'm doing basically reading all the packets in it, which has a destination port of 8000. Why 8000? Because if you see here, this was the one where we saw that I would show you again. This was a communication. This was a port at which we were seeing that the data is ... and basically where we identified the IP/ID values being abnormal. So yeah, let it scan, and yeah, so this was a port, right? 8000. So that's the reason why I'm looking for all the packets which has destination port 8000, and I'm printing the IP/ID values for it. So if I do enter, I just get all the IP/ID values, right? So let me copy this. And if you see here, these are the ASCII characters which are getting, right? Now, what you now do is basically map this to the alphabets which you get. So 103 is G, and similarly you do it for the other alphabets. And this is a message which you get. Sorry, give the credentials in file. So this is the message which it is trying to communicate to your to the script which is running at the on your end system. Basically, in this case, JDOS system. So 103. So as I mentioned that you basically map all the alphabets for this values. So 103 corresponds to G, 105 corresponds to I, and similarly you do it for other. And this is the message which you get. Give the credentials in file. Now this gives another hint that it looks to be that there is some data which would be exfiltrated post this communication. So let's look that is there any other communication between 10.10 and 30.30 on some other port where the data is being exfiltrated or not. So we know that on port 8000, it is trying to send the message, give me the credentials of the file. Let's look for any other communication. When I say other communication, it is like same IP address, like 10.10 and 30.30, but any other source and destination port. So in this particular case, I see that there is another communication which is happening. As you can see that the ports are different, 8500 and 57670. So let me do a follow TCP stream. So that's scanning. In this particular case, we would come to know that whether any data which was being exfiltrated, because it started with this is a secure communication channel, then it's try to send some information like give me credentials of the file through IP/ID. So there has to be some data exfiltration which should be happening. And as you see here, we do see some data, right? This is an ASCII value. So I did a follow TCP stream, and basically it shows me this. Okay, but what is it, what the signature looks like? So it starts with PK. Now, generally, if you have seen, if it's a zip file, the signature starts generally with PK. So does that mean this is a zip file? Could be not. So let's look more into the payload or into the signature, and we see that it's a Word document.xml, which tells us that it can be a Word document file, isn't it? And then the signature just goes, and then ends with this PK. And again, it ends with Word. So it just gives me some confidence that this looks to be some Word file which has been transferred. But let's look into the contents. What were the contents in the file? So the way you do it, or the way you export it, is you convert it to raw, and then save it. So let me save it to downloads, and you can give any name. So in this particular case, j8o_file. Okay, so it got saved. So as we know that it's a Word file, let me try to open. Okay. So as you could see here, yeah, for session perspective, I just mentioned hidden info. But in a real scenario, when J8's machine was being compromised, this file, which would be having all the credentials in it, right? Any file which might be having credentials for critical servers, that was being exfiltrated by the attacker. So so once he gets this files of the credentials, the next step is for him to just log in into that system with those credentials, and then just extract all the secret information which the organization would be having in those critical servers. So that's how the data exfiltration can be, it can be a win situation from a hacker perspective, but it's a great loss from an organization perspective. So this is how the data exfiltration took place in this case, where we understood that what was the hidden information, what was the message it was trying to communicate, and then what was the data it tried to exfiltrate from a raw PCAP which was given to us. Isn't it interesting when you actually do it, in a live scenario where you have got this PCAP, and when you find this information, that's when you advertise yourself and tell that, hey, I was able to crack, or I was able to determine that how this system was compromised. Okay, so that brings us to some hands-on exercises, right? So this is yeah. So basically, this is the installation phase. So these are the questions. I would just run you through how you take this PCAP. So basically, the PCAP which we would be looking for is a name called installation, right? So let me open that. So any questions before we do a hands-on? I mean, this was a live hands-on. How would you look for an incident, and how would you investigate and then come up to a conclusion?
Yeah, one small doubt.
Yeah.
Yeah. So you had this file, and you this image file. You automatically assume that it is a encrypted file, right? So how did you come to conclusion that it is RC for encrypted?
Yeah. So again, I said, right, that's a good question, right? Because generally, in forensic investigation, no one is going to spoon feed you, right? Everything you have to, keep on digging for more data. So in this particular case, the first hint was that there was some kind of printable characters which I was getting, right, in the form of no crawler, and there was some kind of non-printable characters which I was getting after that. So the first thing which I concluded was that, okay, it looks to be some kind of encryption, because there is a combination of printable and non-printable characters. So it looks to be some kind of encryption key and some kind of text which needs to be decrypted with. And then basically, again, it's like trial and error where you run through different encryption algorithms. You fail at some times and you are successful at some times, right? So in this particular case, I ran through different encryption algorithms, and then I came to know that it was RC4. It was not like just looking at the payload. I came to know that, okay, it's a RC4 encryption. Never. That doesn't happen. Does that answer your question?
Thank you.
Yeah, and in this particular case, so as I mentioned that this entire PCAP, I developed it from a session perspective, right? So I know that which kind of cipher I used to encrypt that image. So maybe that was easier for me. But in a real world scenario, if I get this payload, I would just do a trial and error. I would run through different encryption algorithms, and the one which hits it means it's successful. That's how you go about it. There's no secret apart from that. So that's how you approach. But as and when you keep on looking more samples, like now today you might look at this Wireshark sample, may be difficult to gauge, right? I mean, there are so many information to look into. Where do I start from? Where do I end to? But generally, when you start practicing, when you start looking at multiple samples, then you have one idea. I won't say maybe this steps would always work, but at least you have a fair bit of idea that, okay, generally the data gets hidden here, generally the data gets hidden here, and then you start from there. It could be possible you might be successful, you won't be successful, and if you are not successful, it means you are convinced yourself that, okay, the data where I was looking for does not look to be correct, so let me look for other options. Like in this particular case, right, generally the data gets hidden in the TCP payload, but the example which we saw, it was not in TCP payload, it was in the IP-ID feed. So that is, you by looking at multiple samples, then you get a fair bit of idea that, okay, the IP-ID value is generally this in thousands, but it's giving me some decimal values. It means it looks to be suspicious. So that's how you build your train of thoughts and then work on it. Okay, so this is the first hands-on which we have, right? So these are the questions which we have. So what is the hidden file? Is there any hidden file? We need to find first. What is the encoding format? And what is the decoded content exactly? So let's try to answer these questions one by one using the technique which we just now learned in the previous exercise. So this is that file, installation.pcap. So as you can see, it's much smaller file, right, as compared to the previous one, because again, this is not from a large enterprise network. It's basically taken from I mean, it is being built for the purpose of hands-on, so that's why I just kept it small. Okay, so again, from the initial analysis standpoint, you always start with understanding which are the different protocols which are communicating, and in this case also it's TCP, which is close to 100%. And then you look for the different protocols. So in this particular case, it's HTTP looks to be more prominent, where some data is being sent, and also there is some PNG file which is being requested from the client, similar to the PNG file which we saw in the last exercise. It was being fetched from the travel itinerary document, right? So what do we do here? So the first thing is, we know that it's HTTP, right? So we know that we can always do an export objects. So let's first try to answer the first question which it has. It says, what are the hidden file types? But let's understand that what is the hidden file. The only file which I can see is this PNG file, right? So let me save that. You can also open the Wireshark if you want at your system. So this is the file which I got, right? So the first question, it's asked is what are the hidden file types? Okay, so let me copy this image file in my VM. So I've already copied it. Okay, so the file type looks to be a PNG file, right? So the answer for the first question would be a PNG file. Okay. What is the encoding format of the hidden code and what is the decoded content exactly? Now, generally, now in today's cyber world, cyber security space, right? Generally, you would always try to hide data somewhere or the other. Like as we saw in the PCAP, it was hidden in the IP ID field. In this case, it could be possible that the data would be hidden in the PNG file also. We never know. So the way to identify that is using a binwalk utility, which you get in Ubuntu systems or any Kali machine. So what it does is basically it tells you all the files, all the hidden files which are there, if it is there in this image file. And if you see here, it tells you that it's a PNG file. Okay, it's a image. So TIFF is basically the encoding format, which is fine for PNG. But the interesting thing is here. It says that it's a zip file and the name of the file is hello world txt. So it tells you two things, that it is a PNG file, but there is a zip file hidden in that PNG, which has a name hello world.txt. Now, how do I extract this? Even if you cannot do unzip because it's not a zip file, because you have only the PNG file. Unzip utility won't work on PNG extension. So you have to somehow extract this zip file from the PNG. So the way you do it is utility called DD. So basically, in this case, what you do is you give the source image file, which is the name of the image file, bug me not, and you give your name for zip file. In this case, I just gave bug.zip. And skip is nothing but the bytes which you want to skip. So in this case, skip means the bytes where you want to start reading from. So in this case, I know that the zip file starts from this decimal value 12056. So I would say you skip 12056. And this is nothing but the offset. Basically, offset start from 1. So once I do this, you could see that it extracted those data. And let me now see if that bug file got created, that zip file got created. It got created, right? Now, if I do unzip bug.zip, I say yes. And then it extracted the hello world.txt. Now let's read what is there in hello world.txt. And if you see here, it again, as I mentioned, this is some kind of data encoding, which is base 64. Why? Because as I mentioned previously also, if you see something which ends in equals, it is a base 64 encoding. Now let's try to decode this. So again, there is a utility called CyberChef. This is the URL where you have, it's one of the best encoding and decoding utility which you can always use. So you just type the input and it says, yeah, in this particular case, I just gave a flag kind of in CTF format. But generally, this is the way you extract the hidden data from a zip file. I mean, what we learned here was never to trust that the PNG file is the PNG file. I mean, when I say PNG file is a PNG file, I mean that there's no other data which is being hidden in that. In this particular case, it's zip file which was being hidden in the PNG file. And then I use a binwalk utility to see what kind of zip file and what are the contents in it. Then I use this utility to extract the zip file, and then I read the contents of that zip file, and then since it was base64 encoding, I just decoded it. So that's how you do the reverse engineering if you get a file type, of any type, be it PNG, be it JPG. You always need to use different utilities. Maybe in this case, I use a tool. In the previous case, I use a Python utility to understand what is hidden in the image. So this is how we solved the first exercise. So the first answer was the hidden file type was the zip file. What was an encoding format? It was base64. And what was a decoded content? It was this flag, right? Okay. Now let's look at the other exercise, which is a bit interesting. That says actions on objectives, right? It's similar to what we saw previously. So if you remember previously, the message was hidden in an IP ID field. So in this case, it is on similar lines, but more interesting. I mean, similar to that. So we would see that how we can extract the data from this particular PCAP. So the PCAP you need to open is this one, forensics data. Okay, so let's look at the questions. So it says that how many streams are there, which streams are important, and what is the password of the file, and what is the data in the file. So it means there is again some file which is being exfiltrated, but let's understand it's a Word file or something else, right? Okay, so again, now there's a new PCAP file. It's forensics data. So it would be there in the drive, which I shared. So we start again with protocol hierarchy, always, right? So again, I come to know that the TCP protocol is 90%, rest is UDP, HTTP is 1%. And then I look for conversations. So the conversations, there are not many IPs, 2020 and 10.10. And for TCP, also 10.10 and 2020. And UDP, this one. Okay, so I know that this is the TCP stream. So this is a first TCP packet, right? So in a TCP communication, the first packet you'd always see is SYN. Why SYN is because in a TCP communication, the first three packets which gets exchanged is SYN from the client or from the initiator. SYNAC is basically from the responder or the server, basically acknowledging that, yes, I received your SYN and acknowledging it with the SYNAC. And then the client basically acknowledges it. And after this particular packet, the TCP communication is established where this starts communicating the data which they want to transfer. So let me do a TCP stream in this. Okay, nothing. So this doesn't reveal anything. Let's look for this. Okay, it says that I'm your friend. How are you? I have an offer for you, and you can earn this amount of money. Are you interested? And the client says yes. Okay, this looks interesting. So what we saw till now was that this particular stream, the communication was initiated from 10.10 to this server 2020 and responded with those offer data that I have like 1,000 rupees, $1,000 for you to win. And the client says, yes, I'm interested. Generally we do it right on a website. When you go on a website and it says that you have a chance of winning maybe X amount of money, and we get excited and we click on that link. So that is what the client has done. Okay, apart from that, there are some HTTP requests, but there's no image which is being shared or downloaded. So the stream doesn't look anything of importance. But let's look, this is the other stream. It says the same thing. Okay, this was the same stream which we saw. Okay, 43196,000. Okay, this is the another communication which is happening on another port 381656 and 2000. So let's see. Okay, so if you see in this particular case, right, the server or the hacker is trying to ask the client machine, once he entered yes, is trying to ask to the client that what is the key. So this communication happened on this between the same IPs 10, 10, 10 and 20, 20, 20, but different set of ports 38156 and 2000. So let's see that whether the client shared the key or not, right? So let's look for some other port, which is 52674 and 3000. The key is in 4500. What do we mean by 4500? Could it be a port number? Maybe. Let's see. Yes, it looks to be a port number, right? So the port number information you can always see here. Source port is 4500, destination port 52056. So let me do a TCP stream on this. Voila. So we get something here, right? It looks to be the key. So if you see here, it's the key looks to be forensics. Yes, you can always ignore the special characters in between like dots and commas. It looks to be this is the key for some file, which means let's see that the client has shared the key, but has it shared the file also to the hacker or to the attacker? So the key was shared in port 4500. Is there any other communication apart from 4500 where the data would have been shared or exfiltrated? So there's one communication which I see on port 54760 and 5500. So let me do a TCP stream. Okay, so I do something. I do see something, right? Again, this looks to be a signature similar to the previously which we saw where it starts from PK, but this time I don't see any signature for Word or dot or Word doc XML. I do see that it starts with PK, ends with PK, and it looks to be the file which is embedded in it is hello.txt. So it looks to be a zip file. So the way we saved it last time, right? Let's save it. And let's say exercise. Okay. But we know that this is a zip file, right? It's not a Word file. Why? Because we do not see any signature for Word doc XML. And as I said that generally the signature of a zip file starts with PK and ends with PK. So I would just change the extension to .zip. Okay. So let me unzip it and it's asking for password. You remember we got the key as forensics with F capital. So let me type that. And I get this file hello.txt. And again, I get a data encoding format which is in base64 because it ends in equals equals. So I go back to my CyberChef utility, paste it there, and I get a flag. Okay, so if I have to answer the questions, it would be how many streams are there on which the communication is happening, right? So streams, you mean the source and destination IP address, basically the TCP transactions on which the data was being transferred. So if you see that this was one TCP in this particular case, The data which was transferred was, this is not a data. This is just a random communication which is happening. So we can ignore this. The other was this happening on port 2000. So what was the data on this? Again, this was just a random text asking for a key, and the key was actually transferred on port 4500. So this was one of the valuable data forensics. So the stream which you mean, the stream is nothing but the source destination IP, source IP, destination IP, source port, destination port. So this is one such stream where the key was exchanged between 10.10 and 2020 on this port 52056 and 4500. And the other stream was where the actual zip file was being transferred, which was this, right? Which was between that IPs, the zip file was which was being transferred, same IPs, but the ports were different, 54760 and 5500. So the answer to this question was that how many streams? There were two. Which streams are important? Which streams are important and reveal data? It was the last stream, right? Where this zip file was being transferred. What was the password of the file? We know it was forensics. And what was the data of the file? We know that it was this. Okay, so that brings us almost to the end of the session. Yeah, so there is another. So what I would do is I would just have the floor open. So I have this one pcap file which I have shared right on the drive, which is called channel.pcap. I would just like you to try on it, maybe in a week's time, and then maybe on the email ID I would just share you how to solve that. It's one of the interesting challenges, or one of the interesting articles which I read about, and then I built a challenge on that. So it is nothing but a covert channel attack. You can always read this reference article. What do you mean by covert channel attack? So that pcap file is basically built on this concept, covert channel. So what is covert channel is basically you hide the data in different in different headers. It could be TCP header, it could be IP header, it could be Ethernet frame header. So your task has to be that you have to first identify where is the data hidden, and then see that is there kind of message, secret message which is going on, and if you can intercept that. And the final message is again in the form of this. So I would just give you that hint. The final message is in this form: flag, braces, but inside it can be any any alphabets basically. So you have to identify what is the message which is being sent across. And yeah, it involves whatever we learned in this session, but it just has to be one step ahead of what we learned during this session, right? So I just want to make it a bit fun. So I just want you to try, and maybe in a week's time from now, right? Or today is what, 15th? On 21st or 22nd, I post the solutions in that email. I have the email of all the participants, right? So I would just reply in that how to go about, how to go about in solving those PCAP. So does that make sense? I believe it would be interesting for you to also apply the concepts which we learn here. Okay, perfect. So yeah, so that is a covert channel is something very interesting, and it's very difficult to detect. And due to time constraint, I had this challenges, but yeah, going ahead with more time in hand, I would love to have more concepts explained, and also at the same time more hands-on exercises, right? But yeah, that particular challenge I would really like you to take it upon yourself, learn whatever we have learned so far. Those concepts needs to be applied, but yes, as I said, it is one more step ahead to what we learned just now. So that one more step ahead is something I would let you to figure it out. It would be a bit difficult. What I would do is, like, maybe 3 days down the line, I would just give you one hint. And like one hint, I've already told that the answer is in the form of flag. But another hint I would give you maybe in 2 days timeline. That would just help you in thinking that direction. And okay, one hint I can give just now is that there's some kind of encryption which is happening. There's some kind of encryption which is happening in that, and you just need to determine. So for an encryption, you need two set of values, right? A and B, and then the encryption, basically you do something with A and B and you get C. So you have to find that encryption algorithm, and also most importantly, you have to find those values A and B. So wait for my hint maybe in 2 days down the line, and I hope everyone should get it. So sorry. Yeah, so I think that's it from my side. I hope it was a learning experience for you, and also at the same time, fun. Just last but not the least, maybe you can go to the same Menti code if you want to share your feedback on the same code. It's 6814068. Let me ping this.
Thank you, sir. That was a very informative session. I'm sure the participants were able to learn a lot. Now, may I invite Dr. Vinod P., Professor, Department of Computer Applications, to conclude the session and present the certificate as a token of our love and gratitude.
Bhavik, can you stop sharing?
Yeah, sure.
So thank you, Bhavik, for sharing your knowledge on network forensics. It was really nice, and especially the use cases that you took was really interesting. So and really thank you. Like we just had a short discussion, and you agreed for participating as a speaker for this international workshop, and we look for further collaborations with you and your team. So on behalf of the entire members from Department of Computer Application, Cochin University of Science and Technology, I thank you for accepting our invitation and sharing your knowledge. So looking forward to hear from you, Bhavik. So this is a small token of appreciation from the Department of Computer Science and Application. Thank you. Thank you, Bhavik.
Yeah, thanks, sir. It was, first of all, a big thank to you, and also to Subbu sir, for giving this opportunity, to express, or to express my knowledge, whatever I have, and whatever knowledge I learned. I always have this passion to keep on sharing of what I learn, and also at the same time take from others also, who explore in the cybersecurity space, because I always believe that as an individual you always keep on learning. It's not something that you know everything, but you always learn in bits and pieces, and you also learn from your peers. So yeah, it was a great experience, and as you said, for sure, I mean, this is not the end. This is just the start, and I hope to collaborate more in the future with more interesting sessions, with more time in hand, and with more hands-on exercises. So yeah, looking forward to it.
Yes, Bhavik, we will be having a series of sessions in the coming months. We'll definitely be in touch so that maybe like we can learn a lot from you. Thank you.
Sure.
Thank you for
Yeah,
joining. Thank you.
sure. Thanks a lot.
Thank you. Bye-bye.
Have a good day. Bye.
Bye.
A gentle reminder, all the participants, our next session will begin at 12:30. So please be joined at 12:30. Thank you all.
Swapnil, can you hear me?
Hello, Mr. Vinod. Yes.
Yeah. So like we have your sessions beginning at 12:30.
That's right.
Okay. Okay. Thank you. Thank
Thank
you.
you.
Thank you. Thank you.